Hey there and welcome to another Shroom Lab video. This time it's all about magnets. In fact, it's about neodymium magnets, and I recently played with them preparing another experiment, and unfortunately two of them broke. So I have two scrap pieces of magnet, and my idea was it might be interesting to extract the neodymium from them, or at least to try. As you see, this video was not particularly successful, but you'll see it on your own very soon. So there's another magnet, this round bar magnet. This one has a corroded nickel plating, and it's already corroding, so I will add this as well to the magnet scrap. And I thought, what happened, I just give this a perfectly new and working magnet on top of it, just to have a bit more substance, because I'm not breaking magnets every day. And my first idea was maybe I enlarge the surface area before processing them by smacking them with the hammer. So I've covered the hammer with foil, because otherwise these little pieces will stick to the metal and I probably never get them off again. But these magnets are damn resistant. It's basically no chance of destroying them. So I really gave them a good blow, and they survived pretty much without any damage. The only thing that was taking damage was my work plate and the foil on my hammer. But what did work was using this plier here to simply cut through the rod magnet. It just snapped in half, and I thought, well, I just need to break the nickel plating to allow the chemicals that I'm showing you now to hit the magnet. So first I'm dissolving it in acid, filter the boron, precipitate the iron with aluminium using a redox reaction. Then I'm going to filter the iron sponge that precipitated, oxidize all iron 2 chloride to 3 chloride by air oxidation, get rid of the water. Now the nice part, convert the aluminium chloride, which was generated as I precipitated the iron, to oxide, and then heat this up very strongly to get these conversions going and vaporize iron 3 chloride. And you should be left with only oxide and the neodymium chloride, and this can be easily filtered off. So here it starts, bit of water, bit of this acid that sat on the shelf and somehow reacted with something in the air. So the air in my shelf is quite bad, I suppose. There's everything, ammonia, hydrochloric acid, and it probably, the mists out of these not probably sealing containers created this white stuff. It looks a bit creepy, like there was some snow in my shelf. Right, it isn't. I did not do much of calculation here. I just added as much acid as I thought it was needed to be to dissolve all of the magnets, but this was my mistake, because I got fooled. The outer nickel plating didn't dissolve. I expected it to dissolve, but it did not do so, and I added way more acid than it was needed. So I had way too much chloride in the solution, and as I added the aluminium, it first reacted with all the hydrochloric acid, and that way I brought way too much aluminium in this whole reaction. So this might be a reason why it did not go well at the end. And if I break magnets the next time, I'll definitely calculate the amount of acid and not just deduce by eyesight. However, I still decided that you might want to see this experiment, because it's still quite fascinating. So here you can see already brown color of the water, and this is boron that is precipitating out, because these magnets made from neodymium iron boron compound, neodymium and iron, they both dissolve, and the boron will just precipitate out as elemental boron and stay in the solution. I pinned the magnet scrap to the side to pull it out using another magnet, and you can clearly see now that it's just the nickel plating left. Just the nickel plating that covers the magnets to make them corrosion resistant. And surprisingly enough, the brand new magnet I did throw in, I didn't break it beforehand, and it was left completely intact. So I just thought, well, you did survive, you don't deserve to be dissolved. So I saved him, and now he's just a regular magnet. Lucky for the magnet, bad for me having less neodymium inside of it. Here you see it's basically untouched, so the nickel plating did a really good job at protecting the magnet from the HCl. Next step is to add the aluminium and precipitate the iron. I could have filtered this first to get rid of the boron, but I thought I'd do this just in one step. Adding aluminium foil, waiting until it reacts, and then taking off the iron. Here you see it's bubbling, and that's mainly because it reacts first with the HCl that is left in there, because I used too much acid, as I already said. So this spare acid is reacting first, and then it will react with iron chloride to do the redox reaction. This also released a lot of steam and stank horrible. So I really need to calculate the exact amounts next time. Here you can see my hand, and it's all stained from the iron chlorides and the acid, and I'm really lucky that I wear gloves, because otherwise this would have been a stinky mess to clean from your fingers. What you see in here is the whole product after one night, and you see there are a lot of magnetic particles inside. So actually all the iron particles that were reduced by the aluminium clumped together somehow overnight and formed this magnetic sponge and blob of iron. I used a magnet to collect as much as I can and collect it at the bottom. It would have been even better to put a large magnet below the flask and leave it overnight so that everything will be pulled to the bottom, even the fine particles, but I thought I will just go with filtration straight on without allowing this to precipitate. This took a while. As you can see here, the paste is very dark slurry, but it eventually passed through the filter and left behind iron and boron. Here you can see the remaining iron sponge, and it quickly became brown on the air, which means that it oxidized. This can be seen throughout the rest of the video, and it's really hard to remove the last bit of iron from that. And removing the aluminium is not a big problem, but the iron is always staying in there, persistent. As you can see here, it has not a really iron green color. There's some blue shade mixed into it, into the filtrate, but it's still green, and it means there is still iron in it. But I first want to get rid of the water, so I'm giving this a boil on the hot plate to remove the water first, and I also allowed this to sit to oxidize the iron in the air to iron free. The steering does a very good job at this because it introduces oxygen into the mixture. Here you can see it after drying. There is some blue color at the top. I believe this to be neodymium because this is unusual for both aluminium and iron. And at the bottom there's green and even brown rust colored. So here is probably the last time where we can see a trace of neodymium. However, neodymium chloride is not really blue, so there is something weird to go on. It's either violet if it's a hydrate, or it's a brown if it's dry. So you see here HCl is coming off, so the aluminium chloride is starting to decompose. And that's basically what we need to do to get it to aluminium oxide, which is insoluble. So among this brown mass there might be neodymium, which is brown if it's not hydrated, which I suppose because I heated it. There might be iron, and which is also brown, and of course there's aluminium chloride. And now for the final step or steps. The remaining aluminium chloride has to be heated to decompose into aluminium oxide, water and hydrogen chloride, and the iron-free chloride will vaporize at around 300 Celsius, and that can't be done with this little burner here. Actually, I thought this little this is a wheat burner. I thought this is much more powerful, but it's cold outside. The gas is not really has not a high vapor pressure, so this didn't work out. So time to bring out the big guns. Put the crucible inside an insulation chamber, and here you see this little wimpy guy. It didn't do its job. So time for this one. 25 kilowatt propane burner, and I'm quite sure this one will make the job. Maybe I even heated it too much, because after what I have never seen anything being able to extract anything from the mixture inside of the crucible. But you can see these stones, these insulation bricks, they are all white now, and the spider was already dead. I'm really sorry, but it was just a corpse and it died, I don't know when and where. So now we give it as a tribute to the flames. And you just look at the stones, the bricks are all white now, and later they will color dark because of iron-free chloride vaporizing and condensing on the inside of the furnace. And you see it's gradually heating and making sure that really all of the aluminium and iron-free chloride gets converted. Maybe too hot, I don't know. I heated this to around 1000 C. Maybe this already melted the neodymium chloride somehow into the aluminium oxide and it just glassified and never, that's the reason why it never became soluble. So here in the back you see the brown stain in the bottom of the screen. That's iron-free chloride. Here are the remainings. Crucible shrunk in diameter, so quite a lot of it burned. And this thing here is for the next video. It's a vacuum induction furnace I want to show you. And time to dump the remainings. So there's pretty fine powder. Brown aluminum oxide is white, and I crushed this with a mortar and added water to this, but nothing came out. So I guess that will be the end of the video, because it would just be not interesting to show you anymore. I might try this again, but at the moment that's it. So thank you for watching, and stay tuned for the next video on the induction furnace. you got a little sneak peek on that. Bye.